Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another computer science lecture. So we were discussing section number 10, Boolean logic, which was previously known as the chapter number 3, logic gates. In some syllabuses other than Cambridge, this is also known as Boolean algebra, this topic. So we have previously discussed all the 6 gates and how to make different gates from using NAND gate only, and why we do that, and we also discussed how to make a logic expression and a truth table from a given logic circuit, how to make logic circuit from a given expression or logic statement, and we also discussed how to solve a scenario based questions. Now in the new syllabus there would be something new that is going to happen from 2023 and onwards, June 23 and onwards, that now the examiner would ask you to create a logic expression or a circuit from the given truth table. For example, a question would come like this: create a logic statement from the given truth table. Now what you need to, how you solve it? For solving, step 1, first of all check whether the output column contains less ones or less 0 outputs. Over here in this example I have 1 2 3 4 5 zeros and 3 ones, so that means the number of 1 outputs are less. So what I'm going to do is check where the output column shows the 1 or the 0, means wherever it shows that output which is occurring less, put a mark next to it using your pencil or your pen, like over here, and over here I'm having a 1. If it was a different table where zeros were occurring less, then I would be marking zeros. For example, if this table was given to me, we have already solved this in our previous lecture. Over here there are 3 ones and just 1 0. So in this scenario I'll be going with this one, I'll be marking this one. Whichever output, either 0 or either 1, is occurring less in the output column, you are going to mark that. Okay, this is the step 1 and step 2. So I marked it. Now what you are going to do is, what is happening over here, see the first line. It is saying that A is not 1, B is 1, and C is also not 1, and you would get the output as 1. So what we are going to do is, it would be written as, convert this into logic statement. A naught means A is 0, B and B and C naught. And make it into a logic expression. Just this line, the very first line, we have converted it into a logic term, a logic expression, like this. Okay, then convert the rest of the 1 outputs into logic expressions too. How? Like the next line we have is A is 1, B is 1, but C is not 1. So we go with A is 1, B is 1, and C is not 1. So A dot B dot C bar, and the last one we have all are ones, means A is 1, B is 1, and C is 1. So A dot B dot C, bracket close. Now between the 3 brackets or the 3 logic terms which you have just made, you need to apply an OR gate. So this basically means that you are going to get an output as 1 if this condition is there, or this condition is there, or this condition is there. If any any time this combination of ABC or this combination of ABC or this combination of ABC occurs, then you are going to have an output of 1. I hope you have understood it. So this is known as sum of products. Okay, in Boolean algebra or Boolean terminologies, this method is known as sum of products. Just write them together and you have your logic expression. You have successfully converted your truth table into a logic expression, and now you can use this in order to draw a logic circuit. If there are more zero outputs in if there are less zero outputs in output column in the given table, use sum of product. If we have less ones, then we use sum of product, and otherwise we use product of sums. Product of sums, that is POS. Instead, on the rows where the output is 0, means between them we apply an OR gate. Like over here, A is 0, B is 0 and C is 0, so we go ahead with A plus B plus C. Sorry, this is in reverse. This should be A bar, B bar, C bar, and this should be A, B, C, and you are going to get the output as 0. Now apply OR AND gate between them, means simply multiply these two logic terms together and you are going to get your output. Let me just correct this image. There is a slight problem with it. Okay, so I have now made the corrections and it is now accurate. This is the problem in taking images directly from the internet. Sometimes they are having errors. Anyways, I have corrected. So you add them together and then both terms or both brackets you multiply them. Like if you do not have A, not have B and not have C, then you're going to get the output as 0. This is what this bracket is saying. And if you have A is 1, B is 1 and C is 1, then you would get an output as 0. This is not the output column, this is the working column. Otherwise it's not possible that it is 1 here, and I should change this as well. Okay, so now I have corrected. This is the working column basically. So if A is 1, B is 1 and C is 1, A plus B plus C, then we are going to have the final output as 0. Okay, now these two terms, or as many terms as you would get from the table having an output of 0, since we have applied OR gate between the terms between different inputs, then between the brackets we are going to apply an AND gate. Hence product of sums, because this AND gate denotes multiplication or product and these OR gates are denoting addition. Okay, this is the main rule which you need to remember. If you have less number of zero outputs, then we go with product of sums. Otherwise, if we have less number of 1 outputs, then we go with sum of products. Once you have the expression, use it to draw the logic circuit. Now in this term we have an AND gate in between, so we would apply an AND gate over here and then we would accordingly make our logic circuit like we discussed in the previous example. Whereas right now I'm going to make for this A bar dot B dot C. So A bar means I need an A naught, and what else I need? B and C. I have and between them I would apply an AND gate. Okay, and then this AND gate would go into another AND gate with the C. Like we discussed, if we have three terms, then this is our final gate, and whereas these two combine together and they are joined with this one using the gate in between. And over here we have successfully completed our first bracket. I'm going to do the same with the next bracket, A, B and C bar. And then finally I join it with C bar. Okay, this concludes our second bracket, and the third is ABC. So this is a connection from A, this is a connection from B, and we just stretch it out. This is our A, then we get a connection from B, this is A dot B. Now we have to connect a C into it. So I'm gonna take a C from over here. Oh wait, the last one was C bar. So I'll simply add a C bar over here, and I'll instead take my connection from over here before the bar. And this completes our third expression as well. Now we have OR gates between them. So between the two AND gates, one with the A bar and the other one with C bar, we are going to apply an OR gate. Means this one, and between this one we are going to apply an OR gate. There you go. Now we're left with this OR gate and this AND gate, and we are left with this OR gate over here. So we would apply our final OR gate at X like this, and we'll have to connect these both gates with this OR gate. Depending upon the complexity of the truth table or the design, this can be very tricky to do. I have no option but to do it over here. Okay, and then I'll connect this with over here. This has become very complex, but we have officially converted our logic, our truth table, not this one, this one, into a logic expression and then into a logic circuit. Okay, and if you're talking about this one, then again you would do the same thing. You are just going to follow this logic statement and you're going to convert it into a logic circuit following the same rules which we have already discussed. Okay, this is it. Section number 10 has been officially completed. There is nothing else to be discussed in section number 10, or nothing else left to be discussed in logic gates. I hope you have understood everything. If you have any problem, feel free to ask me. Take care. Allah Hafiz.